The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Hello, and thank you for joining today's webinar. We'll be starting here in about 3 minutes. Thanks. Hello, and thanks for joining today's webinar. We'll be starting here in about a minute or so. Hello, and welcome to the VEST webinar series. I am Frank Newsom, your moderator for today's webinar session. And today we will be showing more on how subsystems can be leveraged in HyDraw. Today's webinar will last approximately 30 minutes. You'll be able to submit questions or comments at any time during the webinar by posting in the questions section located within your webinar control panel. Questions may be answered as they're posted, or we will try to address as many as we can in the last 5 minutes or so of the webinar. Today's session is being recorded, and note that the audio is muted for all attendees. If you are experiencing any technical issues, please use the chat window to alert our support staff. Now it is my pleasure to introduce our speaker for today's webinar session, Carlo Malone. Carlo has worked in the hydraulics industry for many years and currently manages application sales and training for VEST desktop and cloud products. Carlo?
Thank you, Frank. Thank you, all attendees. So today it's a 30-minute webinar. We call it a topical webinar. We'll talk about subsystems, and usually topical webinars are more dedicated to specific functionalities of the software. If you are more interested in a global overview of HyDraw, you should join one of the product webinar, or you can look at the videos that we have posted on YouTube or VEST website. So you can see my screen, and I start from the library manager to pinpoint where a subsystem are located. So today we'll make some practice a bit on subsystem creation, management, and so on. So a subsystem for HydroCAD is basically like a super component. A subsystem is defined with a symbol graphic. And now, as you can see, I'm showing some examples of a subsystem. So by subsystem, we can describe, with a subsystem, we can describe a manifold assembly, a motor pump group, standard stack elements, complete power units, or really much more than that, complete manifolds. A subsystem should be considered as a super component or really as a starting point for a new diagram you make. In the library, a subsystem is defined like for the components. So if we switch directly to the component just for a second and take an electric motor symbol, with a right click, we can see that we have some commands like edit component type. So like every component, every symbol belongs to a component type, the same happens for the subsystems. So you have the ability to define component types for a subsystem, and you can change the component type by editing subsystem type. So the subsystem type is basically defining which attributes you want to use to define your subsystem. By default, as always, we have 4 main attributes, which are model code, description, manufacturer, and family, but you can add more. If you want to manage more attributes on a subsystem, you must go to the subsystem type, and there you can find the pre-loaded subsystems in HyDraw library. There are not many. We have many more component types. In terms of subsystem, really, you find these 5 as a manifold assembly, power unit, pump motor assembly, sectional valve assembly, and valve stack assembly. And you can create more according to your needs, according to the system that you build. In terms of information, the subsystem will behave exactly like a component. So on the right side of the library manager, we can see all the attributes. We have a component code which can be used for the item ID numbering. We can have design properties like for the components. These for today are the most relevant information. So model code and all the relevant information for our subsystem. We can also have display format like we have for the standard symbols. It's easy to add properties. So let me just do in the pump motor assembly, I'll start with it. It's easy to add new attributes. We can click add a new property, and we can select any attribute, let's say nominal size, if we want to add the nominal size, or we can create new attributes. When we add attributes to a subsystem, we can also define in which position it is going to be displayed in HydroCAD, and we can save. This change now will be applied to the subsystems symbols like it happens for the HydroCAD symbols. Now let's jump to HydroCAD. I have started a new document. During my last webinar, I explained how to, when you switch on HydroCAD, how to not load the Library Explorer and Property Manager. So now in my environment, they are not loaded at startup. So to load them, you just click on the symbol. And this will load the Library Explorer, and we need also the Property Manager on the right. This dialog, the Library Explorer, is now divided into symbols, external ports, and subsystems. So now we switch to the subsystem, where we find exactly what we were looking from the Library Manager perspective. When we insert a subsystem, let me go to the pump motor assembly group. We have two possible behaviors for the subsystem. This option down here is explode subsystem. So if we want to consider the subsystem as a component on its own with a part number, we can just double click on the symbol and place the symbol in the drawing. Now, as you can see, if we look at the diagram, we can see this is a unique block. There are item ID with round rectangle shape. Those are the children. Those are the components that are included in the subsystem. There is also an hexagon item ID, which is the subsystem itself. If instead of inserting the subsystem like this, I use the explode subsystem option, then the subsystem will be exploded automatically in the drawing. And now, as you can see, there is no hexagon balloon. And if I select a single item, I can see all the attributes for the single item. For now, we don't focus on this exploded subsystem. We focus on the complete subsystem. And now we can see that the nominal size is available here as an attribute. It was not available earlier. We added to the library, so now it's available as model data. We can describe this subsystem with the item number. So let me make a small test. I call it subsystem 1, and the model family is a motor pump group, and the manufacturer is Vest. And the nominal size is maybe GN 25. The power rating is 10 kilowatt. And the rated flow is 85 liters per minute. So rated pressure is 300 bar. We can save to the library. When we save to the library this subsystem, now the subsystem will be attached to this symbol. So if we go back to the library manager and go to exactly that symbol, we will be able to see now the subsystem 1, pump motor assembly, Vest. We can do change. I show you this this command. It's applicable also to the component itself. If you realize that you did some mistake, maybe the rated flow is not 85, is 120 liters per minute, you can change in the library manager itself and save. Or from the library manager itself, you can create a new one, subsystem 2, and with different characteristic. Maybe it's 89 and 12 kilowatt. And we can do a save as. So as you can see, we can create several subsystems directly in the library manager. So now what happens is that this subsystem is not up to date with what is in the library. In order to update it, we need to click on the refresh command. Refresh command is able to work on items and subsystems. In this case, it will work on subsystem. We click next, select all, and click OK. So now we will see that we have the 120 liters per minute. Or if we want to change, instead of subsystem 1, we want to go for subsystem 2, we can select from library and do a search in the library, and now we can see 2 subsystems. So from what you see here, you understand that the subsystem is really behaving in this way like a component with a big difference. So a subsystem includes children items. So this item 1, 2, 3, 4, and 5 are children of the subsystem. That means that when we make a part list, we can decide if we want to include or not the children. And we can also renumber the items. So for instance, we don't want the item 1, we want this item to be item 56. So now if we create a part list for this subsystem, we have the possibility to include the child items or not. If we exclude child items, then we have only one item, the subsystem. If we want to include the child items, we click next, and now we can see also the children, which do not have model code because I didn't save any model code to the subsystem, to the children of the subsystem, but it will display the model codes for the subsystem. If you want, you can change model codes to the elements of the subsystems. In order to do that, you can right-click, edit. Now you enter in edit subsystem mode, so you have the ability for each symbol of the subsystem to select from library, for instance, from my local library or from Fluid Power Tools library. We can search for available pumps in this case. Now I'm doing a very generic search in Fluid Power Tools for a pump fixed displacement, so it will list several items. Let's see. Let me escape it. So as you can see in this case, the subsystem, my HyDraw is looking for the online database for components, and it is listing all the families. We can do it on Marzocchi. Let me take a Marzocchi pump, and let me take ALP3. Okay. And now the information are flowing into component 3. The same can work for the other items. We can type in model code information for the coupling, for the bell housing, for the motor, and so on. When we are done with the change, we can click Save Changes to our subsystem. And now this is the new subsystem, and we will be able to update the part list with the item numbers inside. So if we create a new part list, now we will see all the information for the subsystem components. Again, you have the possibility to define which, if you want or not, the children in the part list. There is another option for subsystem. Sometimes you may want to display the assembly ID, the subsystem in front of each item ID. This is controlled by the HyDraw options. So it is controlled under item ID, and the option is called assembly ID. So if you switch assembly ID on, now HyDraw will be able to display the assembly ID for components. It will work for newly added subsystem or when you renumber items. Let me insert a new subsystem. Usually this setting is already part of the template, so that's why it's not automatically changing anything. So as you can see, in this mode, when I place a subsystem, it's subsystem 1, 2, and now automatically it is adding the item 2 in front of each children. When you renumber items, if you run item ID on a subsystem, you have the ability to define to number just the component and also include or exclude the child items. If you don't want to keep a structure in the subsystem children, you can leave include child items. You can start numbering maybe from item 100, and in this case, every item will be independent from the subsystem. Practically independent. Physically, they will be very close in the part list because they will be numbered following the item ID defined for the subsystem. But in this mode now, the part list for this subsystem will not show a structure. Every item will be independent. If you want to break the subsystem, you can just click, you can type explode command. And when you explode, you will need to delete the balloon and also the item ID because they are part of the block. They are not automatically removed. And as you can see here now, I can really handle and modify my subsystem as I want. So I have shown how to manage the subsystem as a component. And if you have a question, feel free to post me. Now I show you a different technique. And let me show you also how to create a subsystem in the drawing. In one of the webinar, I think it was April webinar, I have drawn a mini power pack. Let me go through it. Let me find one technique. This is a new installation of 2022, so I have not customized too much, but all the designers frequently waste a lot of time in moving between folders. In the HyDraw environment, you can add current folders in order to be able to quickly switch between most used folder. So you can delete what you don't need, and you can add folders. So my webinar April HyDraw, and I should be able to open a DWG file. So this was a power pack with let's say that I make something different. I go into my library and place symbols. So this is how I normally create a subsystem. I place my body, and maybe I want to sketch. Well, let me bring the subsystem exploded in this case as power source, and I want to connect it. And I just draw a rectangle as my reservoir. And maybe I make my reservoir as a yellow. And I also make some tank lines going directly here. And same here. So when you want to make just a manually connection line, it's always easier to use non-auto connect mode. I can add everything as here as a subsystem. So in order to add subsystem, you can click Open Library Editor, and you can enter into a folder, or you can create a new folder. Let me call it Power Pack. And inside a folder, you can add a subsystem. So we can click Add and select the part of diagram that we want to add. And when you add the subsystem, this is important because here it's where HyDraw is asking to specify the subsystem type. If you don't want to manage this as a component, you just select none component type. But insertion point is important because it will help with easier positioning. So let me take the P port as insertion point. In this mode now, HyDraw is adding a new subsystem to my library. Let me add also another subsystem as this sandwich element with an insertion point. So as you can see, in this way, I am just adding a part of diagram that I have made in the past as a subsystem. The reason to do that is because I want really to be able to quickly put together diagrams and modify them by using the subsystems. When you do that, in most of the cases, you will use the explode subsystem at insertion. So in this case, I will just place my power pack. And of course, I can place all the other elements. But I may need to modify this component. So I can go into my library and look for in Free Power Tools Bosch Rexroth 4W6H valve, and I can replace it in the drawing. That's a Bosch Rexroth. Drag and drop. And now in this case, I'm just replacing my symbol with a new one. Or I can change the valves. So in this case, I'm going into my building blocks element. I take position 0, and I want to replace position 0 with a different one. Let's put a flow regulator. And this is changing. So in this case, the subsystem is used as a starting point to build other diagrams. It can be used for a mini power pack as well as for a complete industrial power unit. It's only a matter of how you want to leverage the subsystem usage. For instance, I have several other subsystems, like in this case, I have a 3-pump power unit with true return line filters. It happened some time ago to design to draw a diagram for a complete power unit. So why not storing parts of what you find relevant? The subsystem folder structure is very flexible, as you have seen earlier. I have the ability to create folders and subfolders, webinar and subfolders, inlet sections, or sectional valve assemblies. Another good application actually is exactly the sectional valve assembly, where you want to have a complete symbol treated as one item, but you also want to control which slice you want to have in the subsystem. So if we want, we can do that. And let me go to the sectional valve symbols. I take some. Well, this is actually already an assembly. Let me take some elements from Parker. This would be a working section. That's another working section. And maybe I add an inlet section. Later I'll use the stack element, and maybe I add a end section. We can use the stack function and stack maybe to the right. It's not working as expected. Let me stack manually. So this, if you want to manage each single item number, this can become a subsystem. So in the sectional valve assembly, I can add my subsystem. Now I want to specify as a sectional valve assembly, and I want to specify the insertion point, and I may need also to convert directly the symbol in the drawing. I click OK and select the insertion point. So now in my drawing, I have a sectional valve assembly with an item number. I can specify the model code. And if I make a part list, the parties will have the complete sectional valve assembly and then the children. Or if you need to modify it, you right-click, edit. You go inside and maybe change one element of the sectional valve. So we can go to our symbols and take something else. Well, in this case, I have building elements, so I'm just building something. Let's say that we are done and we save changes. So now I have modified my sectional valve assembly in the drawing, and the part list will then be reflecting the changes I have made in my sectional valve. So we have seen how to use a subsystem that is in the library, how to create a subsystem in the library in the form of component type none, or in the form of with component type. With component type, we can specify model data in the library in order then to retrieve the information directly from the library. And the example, I repeat, is we can search for a subsystem, and we find the two subsystems that I have created a few minutes ago. There is another need which you may have, and is the build a subsystem on the fly. So in HyDraw CAD, for the symbols, there is a command called convert to HyDraw. This command is able to create, to transform AutoCAD entities into a symbol, into a block. So if we run convert to HyDraw for just this rectangle, we are able to transform this into a reservoir. We can select the object, select the entity, and the insertion point, and click convert. This command is able to create a symbol on the fly. There is not an equivalent command for the subsystem, but there is a technique that you can use in order to create a subsystem on the fly. So the technique I suggest is you should build like a placeholder symbol. Let me, this is an example, but let me show you. So you do once and then you are done. So let's say that this is your placeholder, and you add to your subsystem library just a symbol as a subsystem. That's a manifold assembly, and with this insertion point. So I'm adding to my library a subsystem on the fly, which is not really a subsystem. It's just a placeholder that will be in the library. Now I can place it into my drawing and not explode it, of course, otherwise it's useless. And now, as you can see, I have my item number 26. So now what I want to do is I want to bring inside my subsystem all these entities. There is an AutoCAD function called edit block in place. So we can touch the subsystem, the new block that we have created, right click and edit block in place. Edit block in place is a nice functionality of the AutoCAD engine, because it allows you to work by looking at what is behind. So we have all this symbol. We can use this command, add to working set, to insert into our subsystem all the symbols that we need. We can also get rid of this placeholder, not a problem. We can leave the item ID where it is, or we can move that. That will not be a problem, because we can move the item ID where we want. When we are done, we click Save Changes. We click OK. And now we have built our subsystem on the fly. This is our new subsystem. It works as a subsystem with an item number. And we can reassign the item IDs. And all the children will then follow with the item number. So if we create a part list for the subsystem, we can see that the item 50 that we have specified now is a prefix for all the symbols that were in the drawing. In case of item 31 in the for the reservoir, if you want to change it, you must enter into the subsystems. You must do block editor, and you can renumber this, or you can manually number it as item 10 if you want, and save changes. So you have the ability to enter inside the subsystem, modify, and get back to the upper level of your block. So we are running out of time. I don't see any question. If you have, feel free to send an email to HyDraw support. I turn it back to you, Frank.
Alrighty, thank you, Carlo. So that is all the time we have today. So like Carlo said, if you think of any follow-up questions, please send us an email to HyDrawSupport@bestusa.com, and we'll be glad to follow up with you. Again, I'd like to thank Carlo for delivering today's demonstration topic. We would appreciate if you can complete a short survey at the conclusion of today's webinar. Also, tomorrow you will receive an email containing a link to view a replay of today's session. Feel free to share this link with your colleagues. A link to view video segments from prior webinars will also be provided in that email. As you can see, we also have the webinar series posted on various social media channels. We invite you to follow these channels to get the latest updates on these webinars. Our next webinar is scheduled to occur Tuesday, June 14th, where our premier manifold design software, MD Tools, will be showcased. Thanks again, Carlo, and thanks to everyone for attending today's session. Have a pleasant and safe day.